So let's first define what a chessboard is. A chessboard is a game board used to play chess. It consists of 64 squares, 8 rows by 8 columns, on which the chess pieces are placed. So by definition, a chessboard has a dimension of 8 by 8. In order to get the number of squares, we need to get the number of squares that can be formed until it stops. Vertically, it can move the same 4 spaces until it stops. Therefore, we can say that it moved 4 by 4. Hence, 4 by 4 is 16. So, there are 16 5 by 5 squares. For 6 by 6, imagine a 6 by 6 grid line that moves horizontally and vertically. Horizontally, it can move up to p spaces until it stops. Vertically, it can move the same p spaces until it stops. Therefore, we can say that it moves 3 by 3. Hence, 3 by 3 is 9. So there are 9 6 by 6 squares. For 7 by 7, imagine a 7 by 7 grid line that moves horizontally and vertically. Horizontally, it can move up to 2 spaces until it stops. Vertically, it can move the same 2 spaces until it stops. Therefore, we can say that it moves 2 by 2. Hence, 2 by 2 is 4. So there are 4 7 by 7 squares. For 8 by 8, imagine an 8 by 8 grid line that moves horizontally and vertically. Horizontally and vertically, it can no longer move forward. Therefore, we can say that it remains 1 by 1. Hence, 1 by 1 is 1. So there are 8 by 8 squares. From the illustrations from 1 by 1 to 8 by 8, we were able to illustrate how each square is computed per dimension. It is important so that we understand how it actually works in application rather than skipping straight to the answer. But in actual computation, the solution is much simpler than the other method. Computing the squares of a chessboard is just the sum of squares of natural n. So since it's an 8 by 8 dimension, we just take the total sum of squares of 8 to 1. 8 squared is 64, 7 squared is 49, 6 squared is 36, 5 squared is 25, 4 squared is 16, 3 squared is 9, 2 squared is 4, 1 squared is 1. In total, it is the same 204 squares. So the answer for question number 2 is, there are 204 squares in a chessboard. Hard ground. Question number 3. How many rectangles are there on a chessboard? Feel free to pause the video if you want to solve the problem. In order to solve this problem, we have to use a matrix table. Let D be the dimensions. It's the 1 by 1 to 8 by 8 grid lines that move. And let P be the positions. It's the occupied space that the dimension was able to move to. So let's first define the dimensions for rectangles. All squares are rectangles, but all rectangles are not squares. Therefore, we can use the values of the squares of the dimension of the chessboard from the previous puzzle. Now we have the values 64, 49, 36, 25, 16, 9, 4, 1, placed in the respective P. Now we have to get the values for dimensions such as 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7, and 1 by 8, and their vice versa. After which we can use another method which will compute for the remaining values. For 1 by 2, imagine a 1 by 2 grid line that moves horizontally and vertically. Horizontally, it can move up to 7 spaces until it stops. Vertically, it can move 8 spaces until it stops. Therefore, we can say that it moved 7 by 8. Hence, 7 by 8 is 56. So there are 56 1 by 2 rectangles. Also, 1 by 2 and 2 by 1 have interchangeable values for P horizontal and P vertical. Hence, it has the same value. Place the value for rectangles 1 by 2 and 2 by 1. For 1 by 3, imagine a 1 by 3 grid line that moves horizontally and vertically. Horizontally, it can move up to 6 spaces until it stops. Vertically, it can move 8 spaces until it stops. There, we can say that it moved 6 by 8. Hence, 6 by 8 is 48. So there are 48 1 by 3 rectangles. Also, 1 by 3 and 3 by 1 have interchangeable values for P horizontal and P vertical. Hence, it has the same value. Place the value for rectangles 1 by 3 and 3 by 1. From the illustrations from 1 by 2 to 1 by 3, we were able to illustrate how each rectangle is computed per dimension. It is important so that we understand how it actually works in application rather than skipping straight to the answer. For the remaining values, you can use a shorter method since the other method takes too long. If you check the values for P, you can see that it matches the value from the illustrations. So P8 and P7 when multiplied is also 56. When applied, you can easily get the remaining values, so P7 and P6 is 42. In total, there are 1,296 possible rectangles. So the answer for question number 3 is there are 1,296 rectangles in a chessboard. Thanks for listening.